Okay, so don't forget, coming up next week, in fact, a week from today is when you have your second exam, and material from today's quiz is going to show up on that exam. So I would really encourage you to go ahead and start, looking over that material. We'll talk about the quiz tomorrow. Probably going to make next Thursday morning the deadline if you want to retake that. But we've been talking about the unit circle lately. Here's the completed version of it. So the degrees, nobody really seems to be having any issues with those. The axes are in increments of 90. These cluster of 3 points in each of the quadrants, how far apart from each other are they? Okay, they're 15 degrees, but the closest a point is to the axis for those, that's 30 degrees. Okay, now as far as the radians go, we were either adding one of two values over and over again. We are counting by what? Okay, fourths and sixths, yes. If it's a multiple of 45, we were counting by fourths. So 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, all the way around to 8/4 pi, the 2 pi, 1 revolution. So if it was a multiple of 30, remember we are counting by 1/6. So 1/6 pi, 2/6 pi, which becomes the 1/3, 3/6 pi, 4/6, 5/6, all the way around to 12/6 pi. Okay, simplifying if necessary. All right, and then the last point was going to be finding the coordinates, the actual location of the points here, the 16 that we have. Because remember, we are taking the unit circle and we're putting it just right in the middle of a regular Cartesian coordinate plane. So this right here would be the origin, right where x and y intercept. There's the x-axis, there's the y-axis. All right. Now, we did talk about some triangles here, like this point. If you want to go ahead and drop a line, make it perpendicular to the x-axis. This would be a 30, 60, 90. What was always across from 30 in this triangle? 1/2. What's across from 60? Square root of 3 over 2. And then it's the unit circle because the radius is 1. Okay. Now, for the other version, if I go ahead and choose a multiple of 45, if I were to go ahead and drop, again, a little segment here, this is a 45, 45, 90 right triangle. Now, again, the radius, the hypotenuse is 1, but what were the two equivalent side lengths? Square root of 2 over 2, yes. Square root of 2 over 2 for each of those. Okay, so if you're familiar with those, it's going to make working with the trig functions a lot easier. There was another way if you don't want to create some right triangles. In all these quadrants, you'll notice these 12 points, not the quadrantals, all the values are divided by what? They're all divided by 2. Okay, so that's one thing we know about them. So if you were to start here at 60 degrees in the first numerator and count down, so 1, 2, 3, and then 1, 2, 3 back up again. Then take the square root of those numerators, okay, just like we talked about earlier in the week. Okay, but how would having these points help me with the other points? Yeah, just reflect it. I could take these points and reflect them both across the y-axis and then the x-axis, and then either of those two I could reflect them again. Okay, has anybody been practicing the unit circle? Okay, so a few people hands are going up. Okay, I would probably shoot for 5 minutes or less. Okay, because on the test I'm not going to be providing you a unit circle. So if you're going to want to use it, you're going to have to create it on your own. All right, but there is another way that I have that might help you out. Okay, well, here were the ratios we started looking at yesterday. We're going to make a little push away from the opposite, adjacent, and hypotenuse. We want to go ahead and put the ratios in terms of our lengths here. So the vertical length y, the horizontal length x. What's the value of r? Well, it's the radius, but what's the actual value? Yeah, just 1, because we're on the unit circle. And we talked about those points. We like to always write them as x comma y, but we're going to go ahead and replace those. Cosine is your x value. Sine is going to be your y value. And I mean, we can tell that right here. If we're going to say that the radius is actually 1, well, y divided by 1 is y, so sine is equal to y. Same thing for cosine, x divided by 1. Okay. So let's see. I think we were talking about quadrantals when we left yesterday. Yes, we were on this one right here. Okay. And I was explaining to you how these trig functions work, how we want to go ahead and evaluate them. There's really two parts to it. The first part is you want to go ahead and find where the terminal side is going to stop. That's the angle's job. And it doesn't matter if it's in degrees, it doesn't matter if it's in radians. That angle measure is going to go ahead and tell you where to stop. Once you're there, the trig function is going to tell you what to do with the ordered pair that you find. Okay, so let's walk through an example. I need 450 degrees. What do we call it when we start on the positive x-axis? Remember, that's standard position. Okay, so 450 is definitely bigger than 360, so I'm going to rotate all the way around, but how much further do I go? What's the difference? It's 90. Remember, we're still talking about quadrantals here. So 450 minus 360 is going to give me 90. So my terminal side would stop here. Okay. Remember, a quadrantal is if the terminal side stops on one of the axes. All right. Well, as of now, the 450, he's done his job. That's all he's required to do. Now, what's the ordered pair that's there where we stopped? It was 0, 1, right? So this point here was 0, 1. We have an x value and we have a y value. Well, what's tangent's ratio now? Okay. And if we don't remember, we can take a look back over here. Tangent was what? The y divided by the x. See, the ratio tells you exactly what you want to do. I want to take the y value and divide it by the x value. Well, the y value is 1, the x value is 0. So we can't divide by 0. This guy's undefined. So I can't evaluate tangent at 450 degrees. Okay, this is tangent, 450 degrees. And that's it. The angle tells you where to stop. The trig function then tells you what to do once you get there. All right? Like if I wanted to go ahead and say sine of 450 degrees. Remember, what's sine? It's just your y value. Okay, so what's the y value of this ordered pair? 1. So sine of 450 would be 1. What's the cosine of 450? 0, because that's the x value. That's all there is. Let's try this. Now this one is given to me in radians. Does not matter. So the first thing I need to do is find out where 7 pi over 2 radians is. Now if it's an improper fraction, we talked about rewriting it as a mixed number. What would that be? 3 and 1/2 pi, right? Okay, so let's see here. We start at 0 radians. We got pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so I'm going to go ahead and go to 3 pi. So there's 1 pi, 2 pi, there's 3 pi. Okay, now I just want to rotate an additional 1/2 pi. Now remember, pi is only half of a rotation. So really all I have to do is go a quarter more. So right here. Okay. So the 7 pi over 2, he's done his job. He's told me where to stop. Now what's the ordered pair there? The ordered pair on the unit circle there would be 0, -1, right? There's my x, there's my y. So I want the cotangent. Well, what's the ratio for cotangent? Yeah, this was x over y. So I want to take the x value and divide by the y value. That would be 0 divided by -1. Well, that would give me 0. So the cotangent of 7 pi over 2 is 0. That is all there is to evaluating a trig function. You find where it stops, and you do exactly what the trig function wants you to, whatever the ratio is. Okay. Does anybody have any questions? Is anybody confused by what I'm doing? Okay. All right. Well, a quick review. We've seen these before, but now we have a much more mathematical definition. Reference angles. If theta is an angle in standard position, its reference angle, what we call theta prime, is the acute angle formed by the terminal side of theta and the x-axis. Okay, so wherever your terminal side stops, using that and the closest x-axis, that's our reference angle. So in the first quadrant, we've seen an angle can be its own reference angle. In the second quadrant, I'm going to use the negative x-axis. In the third quadrant, once again, the negative x. And in the fourth, I'm going to use the positive x-axis. Okay. The thing about the reference angles are they're always positive. Okay. So let's practice finding some reference angles. Sketch negative 150. Okay, so wait a minute. What is the negative doing? Okay, it's just telling me to change the direction. Remember, positive is counterclockwise, so negative is clockwise. So this would be negative 90, negative 180, negative 270, all the way back around to a negative 360. All right, so let's see here. Raphael, what quadrant would negative 150 stop in? 2. Okay, now we're a little off. Now, if it were positive 150, yes. 3, there we go. So it's going to rotate around like this. There we go. That's negative 150. Excuse me. All right. So where the terminal side stops and the closest x-axis, that's the angle I want. How much further would I have to rotate to get to the negative 180? Yeah, just 30. And remember, the reference angle is always positive. Okay. All right. Again, this is one of the things we've already talked about, but I figured it wouldn't be a bad idea to kind of bring it back up and practice. Okay, sketch 3 pi over 4. Okay, well, let me go ahead and get this ready. 0 radians, pi over 2, pi, 3 pi over 2, 2 pi. Let's see here. How about Shana? Where is 3 pi over 2 going to place me? What quadrant? Or 3 pi over 4, excuse me. The second, there you go. Because here we have 1/2 pi, we have 1 pi, so 3/4 pi would be right between them. Okay, so I'm going to rotate over. This right here is 3/4 pi. Okay, so where that angle stops and the closest x-axis, that's the reference angle. Okay. Well, let's say here, I mean, all I got to do is subtract. If I have 1 pi and I'm going to subtract 3/4 pi, I'm going to have 1/4 pi, yeah. So my reference angle would be pi over 4. Okay. Well, what about this one? Find the reference angle for 520 degrees. Okay. Now, that's definitely bigger than 360. It's positive. So I'm going to go all the way around. Okay, so right there is 360. But how much further do I need to go? What's the difference? I need to go an additional 160. 520 minus 360. So 160 is going to put me in the second quadrant, actually close to the x-axis right there. Okay, so I'm looking for this angle. Well, if I had to go an additional 160 degrees, what's my reference angle? It's got to be 20. That's it. That's all there is to it. Yes, Satish. Well, we're bringing up reference angles with respect to the triangles we're going to go ahead and create. So if you're using it to evaluate a trig function, I'd kind of say dealer's choice. Whatever you think is going to be best for you. Okay. So speaking of, let's take a look at what we have. So here's a full unit circle. Okay. Now, we've already talked about how to evaluate trig functions. There are your steps right there. Let's just get right into a problem and see what you guys think. Okay, so I want to evaluate sine of 4 pi over 3. Okay, I want sine of 4 pi over 3. So I need to do two things. First, I need to figure out where 4 pi over 3 is going to put me. And then once I get there, I want to know what sine wants me to do. Okay, it's always in two parts. Now, if you have a unit circle, okay, this is going to be really easy. So let's say I want the sine of 4 pi over 3. Okay. Well, what quadrant does this put me in? Yeah, this is the third one, right? Because I see 4 pi over 3 right here. So my reference angle, excuse me, not reference angle yet, my rotation, that's where my terminal side would stop, right? Well, because I have the ordered pair right there, well, I would just go ahead and do now what the trig function wants. So 4 pi over 3, I found the location. But what does sine want? Sine just wants the y value. Well, what's the y value at that location? negative square root of 3 over 2. Okay. So the sine of 4 pi over 3 is just negative square root of 3 over 2. So see, if you have a unit circle, it makes it really easy. And all we're going to be dealing with now are the 16 points that we see on the unit circle. Eventually, we're going to go beyond that, but not just yet. Okay, so it has to be one of those 16 points. So let's say you don't have a unit circle. Okay, let's go ahead and take a look now. We already saw that 4 pi over 3 is going to be in the third quadrant, right? So this was pi over 2. This is pi, 3 pi over 2, all the way back around to 2 pi. So let's say right here. So if I started here in standard position, rotated all the way around, there's 4 pi over 3. Now, if you don't have a unit circle, this is why the reference angles are going to be so important to you. You're going to use that terminal side to create a right triangle. Okay. So think about it. 4/3 pi is actually 1 1/3 pi, right? See, there's the 1 pi. So how much further did I rotate? Yeah, 1/3 pi. So what's pi over 3 in degrees? That's 60 degrees, right? See, that's important because if I know that reference angle is 60 degrees, what kind of triangle did this just become? This is a 30, 60, 90. What's always across from 30? 1/2. What's across from 60? Square root of 3 over 2. The radius is 1, but don't forget about this question. Okay? What quadrant am I in? So am I forgetting anything? Yeah, here both x and y would be negative. So negative 1/2, negative square root of 3 over 2. This is my x value, this is my y value, and this is my radius. So remember, sine just wants the y value, right? Okay. That's how I would encourage you to do it. Okay, now if you want to go ahead and work with the unit circle and try to recreate it, you do need to go ahead and be able to do that quickly. Okay, otherwise I would just say go ahead and use the reference angles and right triangles. Okay, let's try another one. Okay, tangent of 150. Okay, tangent of 150. So what quadrant is this going to put me in? 2. Okay, so we're going to rotate over 150 degrees. So let's say there's my terminal side. Okay. Now let's say we don't have a unit circle. Where he stops, I'm going to use that terminal side to create a right triangle. So what would his reference angle be? Okay, so once again, it's going to be a 30-60 triangle. And it's going to be that same triangle that we see over and over again. Remember, we're restricting ourselves right now to just those 16 points that we know about. So we're not going to be getting any reference angles that won't give you one of these yet. Okay. So what's always across from 30? 1/2. Across from 60. And then the radius is 1. Am I forgetting anything? What am I forgetting? Which one's negative? There you go, because in the second quadrant, x is negative. Okay. So see, now I have my triangle, okay, created because I knew where 150 was. What does tangent want? Tangent always wants the y over x. So I'm going to go ahead and do just that with what I have. The y value being 1/2 divided by the negative square root of 3 over 2. And now we just need to do a little bit of algebra and you got your answer. Okay. Is everybody seeing how it's really just those two parts? Use the angle to find where it stops. Then the trig function tells you what to do from there on. What happens if you divide by a fraction? Yeah, you're going to multiply by the reciprocal. So this will be 1/2 times negative 2 over the square root of 3. So those 2's are going to cancel. So I have a negative 1 over the square root of 3. So I have to rationalize. So what should be my final answer? Negative square root of 3 over 3. Now again, just to go ahead and show you the other way, let's say you had a unit circle. So I'm looking at my unit circle right here. Well, I would locate 150 degrees. Well, there's the coordinate. I would take the y value and divide it by the x. But isn't that exactly what we just did? Yeah. Okay, so if you have a unit circle, that's great. But if not, create a right triangle using the reference angle. All right, we should be able to get away with one more of these. Let's try this one. I want the secant of 15 pi over 4. Okay, the secant of 15 pi over 4. All right. So first off, let's go ahead and find out where this guy's going to be. What would be the mixed number? 3 and 3/4. So this right here would be 3 and 3/4 pi, right? Okay, so here's pi over 2, 3 pi over 2, start at 0, go around to 2 pi. Okay, so I'm going to go 1 pi, 2 pi, 3 pi. And now I just want to go 3/4 further. So what quadrant would that put me in? That's going to be in the fourth one. Because remember, half of a revolution, that's pi, right? And I want to go 3/4 of that. So it is going to put me in quadrant 4. Okay? So there's my terminal side. So we'd rotate all the way around to get there. Now here's the thing. After we did the 1.5 revolutions, we rotated 3/4 of pi, right? So what's my reference angle? It's got to be pi over 4. It's 45 degrees. Okay. We know the radius is going to be 1. What were the identical side lengths for this one? Square root of 2 over 2, square root of 2 over 2. Now, because we're in the fourth quadrant, y value is negative. Okay. So that's the first part. We found exactly where we need to stop and what the triangle is going to be based on the 15 pi over 4. What does secant want? Okay, there you go. Remember, secant, he wants r over x. But Satish just reminded us, remember, the radius is 1 because we're on the unit circle, right? So all I want to do is put the x value below 1 and then simplify. Okay, so let's see. Is that the positive or the negative one? That's the positive. Okay. So this would be 1 times the reciprocal. So I'm just going to go ahead and put 2 over the square root of 2. And what do we have to do? Rationalize. So can anybody tell me what my final answer is? It would just be the square root of 2. Because we would have 2's that cancel. That's it. Okay. Let me ask you a question. For the exact same one, what would tangent of 15 pi over 4 be? Remember, what does tangent want? He wants y over x. So this divided by that would just be negative 1. Is everybody starting to get this? Is anybody confused? Okay. All right, good. And I believe that bell should be ringing pretty quick. Okay, so I got that. Oh, and actually, we're about to do this with 5th period, and we haven't gotten that far yet. So I need to erase that. All right, you guys have a great day. I will see you tomorrow.
I was gonna break check Skyler, but
Okay.